Hello everyone, welcome back to our college algebra. Today, in this video clip, I'm going to be talking about section 6.1. It's about composite functions. So let's start with the idea of function. As you know, function, think of it like a machine, okay? So whenever you plug in an input, then the machine going to follow some formula, some recipe, and then it's going to produce an output. And for function, it's going to follow one condition. So for each input, you can only get exactly one output. Okay. So for example, you have a function f of x, say equal to 2x plus 1, and think of x as the input. Okay. F stands for function, and whenever you plug in the input x, and this function is going to do what? Double the x and then add 1, and whatever it is going to give you the output. So say I plug in x equal to 5, and what? F of 5, and what? I plug in 5 to the function, right? And this function do what? 2 times 5. Okay, let's write it this way. 2 times 5 and then plus 1. And that's give you back 11. So 5 in, 11 out. And keep in mind that function will always follow one rules. But each input can only give the exact output to be a function. Alright, so today we'll be talking about composite function. Think of it like a chain of function. So say you have two functions. You plug a function f and then function g. Okay? Say f of x is right here. How about g of x? It's equal to say x squared minus 1. You plug in say x equal to 5 to the function f. And then through the function f, you're going to have 11 out. And now you're going to use the number 11 right here, the output of function f, as the input to plug it to the function g. Okay, so what are you doing here? This is 2 times 5 plus 1, right? You got 11 now. You plug in g, means what? X now, the 11 now, the output of f now becomes the input for g. So what do you do with 11? You plug in g right here, right? G 11 is 11 squared minus 1, which is 121 minus 1 is 120. So this is 11 squared minus 1. You got what? 120 out. Okay? So you actually get the final output is 120. And consider this is what? A composite of two functions to get to the answer. Okay? So first you got 5. You plug 5 into f, you got 11. Okay? 11 now is like the intermediate product. It is the output for f. And we use 11 as the input to plug into the next one, g. And you got the final answer. So first of all, you got 5, right? You plug into f. You got f of 5, right? Now you use the whole thing as the input to plug into g. Okay? Then you have the final output. So 5 is the input for f, and then f of 5 is now the input for g. Okay? And similarly, you can have g of f of 5 right here, 120 right here, as the input for another function. Say you got function h or function j, keep going. Then you can have like a longer chain. And what we're doing right here is the idea is called the composite function. And say you have another h, you have this. Right. Turn out what? We use so many parentheses. So people found a better way to reduce the number of parentheses. So instead of writing this way, this is what? 5 is the input plug into f, f is the input right here, f of 5 the input plug into g, and g of f of 5 is the input to plug into h. And we use 1, 2, 3 pairs of parentheses. Too much. So people are going to reduce the number of parentheses by writing it this way. And little o of g, little o of f of 5. Now we only use one pair of parentheses. People understand what? 5 is the input to plug into f, right? And now what? F is the input for g. And then g of f of 5 is the input for h. And this is the same meaning as this notation right here, just shorter. And that is the whole idea of what we call the composite function. So first, let me give you kind of a definition of composite function and two function, and then we're gonna show you some math out of it. Okay, but this is the idea. Given two functions, f of x and g of x the composite function denoted by g little o f of x is a function defined by g little f of x is actually equal to g parenthesis f of x. So what we're trying to say is this. Whenever we have two functions f and g, if you want to compose f and g, it means what? If you do g of f of x means what? X the input. First of all, you plug into the function f, whatever you have with the output of x, and you're going to use that as the input to plug into g. And of course, you know what? This is going to be completely different from that. This is definition is done. So notice that what? G of f, let me write this way. G of f of x is not the same as f of g of x. You know what this means? X input, first you plug into f. Whatever you have, you plug into g. In here, what does it mean? X input, first you plug into g. Whatever you have for output of g, you plug into f. And usually those are not the same. Okay? Let me try to convince you with that. I'm going to use the same example as before. Say, we call f of x was what? 2x plus 1, right? And g of x was x squared minus 1. So, g of f of x, say, when x equal to 1, I want to calculate g of f of 1. First of all, I calculate f of 1. F of 1 is 2 times 1 plus 1, which is equal to 3. Now, g of f of 1 is equal to g of 3, and that's equal to 3 squared minus 1 is equal to 8. You see what I'm doing right here? First of all, I got x equal to 1. What do? I plug into the function f. I got 3 out. Now I use 3 as the input. I plug into the function g. Okay, so f of 1 is equal to 3. F of 1 is equal to 3. Plug into g right here. I got g of 3, and that's equal to 8. Okay, I got 8 out. So the whole picture is what? 1 is the input I plug in, and the output is 3. And how did I equal to 8? I'm sorry, 8. And how did I do that? First of all, I got 1 plugged into f. I got input for f, it's 3, and then plug into g, I got 8. Okay, so g of f of 1 is equal to 8. This way. Whereas, if I plug into g first, so if I want to calculate f of g of 1, first of all, I do g of 1, right? G of 1 is what? 1 squared minus 1 is equal to 0. G is right here. The g of 1 is 1 squared minus 1 is equal to 0. And then I calculate f of 0, which is 2 times 0 plus 1 is equal to 1. So x equal to 1. First of all, I plug into g. I got g of 1 is equal to 0. And now I use 0 as the input plug into f. I got f of 0 is equal to 1. So 1 in, 1 out. This one is what? 1 in, 8 out. So g of f of 1 equal to 8. F of g of 1, f of g of 1 is equal to 1. Okay? First of all, 1 plug into g, and then whatever you have plugged into f, you got 1 out. Completely different, not the same. Okay? You can try in any number. Okay, so you see it's not the same. So okay, we're going to move on to another thing. Is there any way that we can find a general function, composite function instead of plugging numbers? And the answer is yes. I can compose the two functions in general. See what I got? Say I got what? finding the composite function, right? See, I got f equal to f of x right here equal to 2x plus 1, and g of x is equal to x squared minus 1. Question is, can I find the general function g of f of x without plugging the value? So I have a function in general, and then I go plug in the input later. The answer is yes. This means what? X is the input of f first of all. So this is the same thing as g of f of x, right? So you have f of x now. The whole thing will be the input for g. So this is no more than this. G of 2x plus 1. You see why I have this? Because what? F of x right here is the same thing as 2x plus 1. F of x is 2x plus 1. So actually, the input for g is not x. The input for the function g is 2x plus 1. That's the input for g. And function g right here say what? Whenever you plug in the input, I'm going to square up the input and then minus 1 will give you the output. Again, the input for g is not a single x. The input for g is the entire function f, which is 2x plus 1. And the function g say what? Whenever I have an input, I'll square it up and then minus 1. So this one, I'm going to do what? 2x plus 1 squared and then minus 1. Because keep in mind what? The input for g is not just x, okay? Input for g is, in this case, is 2x plus 1. All right? Here, input for g is x. What do you do with x? X squared minus 1. In this case right here, input for g is 2x plus 1. What do I do with it? Square it up and minus 1. And then you can simplify this. You have the final function. It's 4x squared plus 4x plus 1 minus 1, which is 4x squared plus 4x. Okay? So, final answer. G of f of x is equal to 4x squared plus 4x. Now that you have g of f of x in general, let me write up here, equal to 4x squared plus 4x. Okay? And you don't have to plug in specific number for the intermediate step anymore. You can actually plug in any number into that composite function, you have the answer. So g of f of 1 is actually what? 4 times 1 squared plus 4 times 1. This is 4 plus 4 is equal to 8. Let's match up with the answer right here. Okay. Last time we tried what? G of f of, I think, 5, right? So 4 times 5 squared plus 4 times 5. 5 squared is 25. 4 times 25 is 100 right here. Plus this is 20. You see that's equal to 120. Let's match this up with what we learned before. Let's see. You get the idea ready? Then we can calculate something like, say, g of f. How about f of g? F of g of x. Now what? We have the input x. We plug into g, okay? And then we use the entire function g as the input for f. This, by definition, is f and then g of x, right? And then g of x is what? X squared minus 1. So this is f of x squared minus 1. I'm just trying to explain the meaning of it for you. G of x is just x squared minus 1. You use f to plug into g. The output for g is x squared minus 1. And you're going to use the whole thing, x squared minus 1. That's the input to plug into x. And the function x say what? Whenever I have an input x, I will times x by 2 and then plus 1. So whenever you have the input, this is x squared minus 1, I'll double that thing, multiply by 2, and then plus 1. So this is what? 2 times of x squared minus 1, and then plus 1, which is 2x squared minus 2 plus 1 equal to 2x squared minus 1. So f of g of f going to be equal to 2x squared minus 1. You can try. Say f of g of 1 is 2 times 1 squared minus 1 equal to 1. Plug 1 into g, and then you plug g of 1 into f, you got 1 now. That's what we have. And try any other number. Say f of g of 0, 2 times 0 squared minus 1 is equal to negative 1. Okay. So hopefully we have this example, you guys have some ideas of composite function. How about this? Oh, let me keep this. G of x was what? X squared minus 1, right? How about this? F of x. What do we mean by this? We have more than two functions in here, right? First of all, you have x, you plug into f, okay? Whatever you have for the input, for the output, you use the whole thing as input to plug into f again, and then repeat it one more time. So the output for f of x becomes the input to plug to f one more time. The same way you can have a change of function, more than two, more than three, okay? So let's try to do this one in general. So this is what? F of x is f of what? 2x plus 1. Okay, again, this is how we use a new notation, little o. And if you don't want to use that notation, this is what it means. You see, a lot of parentheses, right? So this is f of x. So let me try to go back here. This is the same thing as what? F of 2x plus 1. Okay? Because f of x is 2x plus 1. Now, f of x, 2x plus 1 becomes the input for f. So what do we do with this one right here? And this is f of 2 times 2x plus 1 and then plus 1, right? Which is the same thing in here. Okay? And then what do we do with this? Can we simplify this a little? Yeah? Which is f of, I think, is that what? 4x plus 3. And again, repeat it one more time. The function f is double the input and then plus 1. This is 2 times 4x plus 3 and then plus 1. And the final answer is going to be 8x plus 7. Okay? So really, this is the lecture, so I try to explain step by step, but usually people can skip some step and try can work on this much quicker than this. Alright? So you can hide all the step and do the calculation on top of your head. Say for example, f of x, so I'll do it this way. Look. X plug into f, I got what? 2x plus 1, right? Okay? And now what do I do with this one right here is 2x plus 1. What do I do with 2x plus 1? I plug into f again, so 2 times 2x plus 1 and then plus 1. Okay? Now the whole thing becomes the input, plug into f one more time. So what? 2 times of the whole thing and then plus 1. And then you simplify. You should have the same answer. Okay? So just write one line. But to some people, I think this is going to look simpler, easier to simplify just one line. To some people, just want to, how the order we have the whole thing right here. So I try to break it out step by step. So it's up to you. Okay. Similarly, say I have a g of x. What do I do with this? What does it mean? So g is right here, right? So g of g is what? G of x is x squared minus 1. Now x squared minus 1 becomes the input for the second g, so square it up and then minus 1 again. Okay. What if I want to do g of x? So this is the input for the bigger function right here. Okay, g of x. G of x is this. And now I'm going to plug the whole thing into the function g. And what does that mean? X squared minus 1 squared minus 1. I'm going to use the whole thing as input, so square it up and then minus 1. It's going to be, you would put another g right here. You square everything up and then minus 1 again. Okay? Try to give you one more example before we talk about another thing. What if, now I'm going to keep the same x right there. What if my g is this? G of x is equal to x squared plus 2x minus 3. So it's just pretty much the same idea. I was just trying to add one more x in there. So the rule for function g is what? Whenever I got an input, I put the input square plus twice of the input and then minus 3 and get the output. Okay? So g of f of x, what does it mean? X input, I plug into f, okay? And now the whole function f is going to be the input for g. And then now I use 2x plus 1 the input. I plug into the function g. All right, g of 2x plus 1. Okay, and the rule for g is what? First of all, square up the input, and plus 2 times the input, and then minus 3. See? Square x squared now 2x plus 1 squared, and then 2x now 2 times 2x plus 1, and then minus 3. And this is g of f of x. Okay. What about g of x? This means what? G of x squared plus 2x minus 3, right? So this is now the input for g. So what does it say for input for g? Square it up. X squared plus 2x minus 3 squared, right? Plus 2 times the input, so 2 times x squared plus 2x minus 3, and then minus 3. Okay? This is g of x. All right? Hopefully, the idea of composite function kind of makes sense to you. Think of it like a chain of a machine. First of all, you have some raw material plugged into the first function. It's going to give you some outputs, right? So you use that output to put in another machine. It's going to give you another product, and then keep going until the end. And finally, at the end, you have a very final product. And that was the idea of it. Okay. Let me move on to talk about one more thing before we start this video clip. I'm going to be talking about the domain of the composite function. Domain of the composite function. Let me talk about the idea first, and then I'll show you how. So we learned about domain already. Think of the x value. What can you plug in? So what? Like f of g of f, right? First of all, f gonna satisfy the function g, okay? And then what? G of x, the output of g, gonna satisfy the domain of f. That was the idea. Okay. X gonna be a valid input to plug into g, and then the output for g gonna be a good valid input for the function f. So it's gonna be 2 layers. Similarly, you got another function, and what? The entire thing right here, f of g of x, gonna be the good input to plug into another function. If not, then you break the chain. Okay. So let me give you an example. You see what we're talking about. Say I give f of x equal to 2 over x minus 1. Rational function. So we can talk about domain. Okay. And then g of x is equal to 1 over x plus 2. Okay. So the domain of f right here, domain is all real number x. X cannot be equal to 1. The domain of g right here is all real number x, and x cannot be equal to -2. Okay? So we have 2 domains. Let me denote it by df. The f right here stands for the domain of the function f, and this is dg, stands for the domain of the function g. Okay, now let me calculate the composite function f of g of x, and then I'll find the domain. So f of g of x means what? First of all, you have the input x. You plug into the function g. You have 1 over x plus 2. I'm going to use the whole thing as a domain. As the input, plug into the function f. So this is what? 2 over 1 over x plus 2, and then minus 1. See? The function f is 2 over the input minus 1. Okay? So f of g of x is what? 2 over the input. Input now is g of x, which is 1 over x plus 2, and then minus 1. All right? And this is the composite function, f of g of x. Question, can you find a domain of that thing? And by the way, this is called a complex fraction, okay? Let's try to simplify this and find a domain. So I'm going to multiply the top and the bottom by x plus 2. You see why if I'm x plus 2 over x plus 2 is just 1. If I multiply by x plus 2 on the top and the bottom, I can simplify the denominator. So the top now is 2 times of x plus 2. And the bottom, the distribution 1 over x plus 2 times x plus 2 is 1, and minus 1 times x plus 2. And let's simplify this a little bit more. Top is 2 times x plus 4. The bottom is 1 minus x minus 2, and this is 2x plus 4 over negative x minus 1. Okay? And to make it easier for you, I can write this way if you want. So you can see the factors in the denominator better, which is negative x, negative 1. It's the same. Okay? So the domain is what? X cannot be equal to negative 1. You see why? Because negative 1 make the denominator equal to 0. But that's not going to be enough.